my name is Sophie, and today I'm going to be talking about the mountain pine beetle, which is a species of bark beetle native to the western forests of North America. And their current outbreak in our forest has spurred a lot of scientific interest in these beetles' role in the climate system, specifically in forests' ability to take in carbon. The mountain pine beetle develops in 4 distinct stages, starting with the egg, then the larvae, then the pupa, and finally the adult. Except for a few months during the summer where the adult emerges to find a new host tree, most of their life occurs beneath the bark. So when a mountain pine beetle wishes to reproduce, it burrows into the bark, lays its eggs, and the larvae feed on the living tissue of the tree, which of course can be harmful towards the tree. While the mountain pine beetle is under normal circumstances a natural part of the forest ecosystem, climate change has meant warmer temperatures which make beetle populations skyrocket, which has increased tree mortality. Science has connected beetle populations with climate change in 2 distinct ways. Number 1 is that beetles like the warmer, drier weather. So as climate change makes winters shorter and more mild and summers warmer, these mountain pine beetles are thriving, dying less, and their life stage development rate has been increasing. Number 2 is that higher temperatures mean that tree defense mechanisms can be compromised. So as climate change worsens and we are getting higher average temperatures, trees are more susceptible to damage by the mountain pine beetle. So this beetle outbreak means that trees are dying at an unprecedented rate in forests in the West. One study even speculated that this change in the forest, specifically in British Columbia, Canada, has changed the forest from a carbon sink to a carbon source due to the combined effect of increased beetles and increased forest fires. Now, this issue of forest fires has become especially important and has some differing scientific views. On the one hand, widespread tree mortality in the West has meant thinner forests, which actually makes wildfires less likely to happen. But on the other hand, these drying, rusting trees that we see are dry and thus can act as kind of a flint for fire, which could make wildfires more likely. Either way, dying trees means bad things for our carbon system. It means that less carbon dioxide is being taken from the atmosphere into organic matter. To summarize, let's understand this climate feedback. First, we have warmer temperatures, which mean there are going to be more mountain pine beetles in these forests. More mountain pine beetles mean there are more dying trees. These dying trees could mean wildfires, but they definitely mean that less CO2 is being taken up from the atmosphere and being transformed into organic matter, i.e. trees. Less CO2 uptake means that there is more CO2 in the atmosphere, which of course, as we know, raises temperatures. As you can see, this is a positive feedback as it is self-reinforcing, which could mean really scary things for our climate system and the future of climate change. So to sum up, the mountain pine beetle is playing a crucial role in our carbon cycle. This outbreak needs to be taken into account when we're talking about climate modeling. The positive feedback is rather scary because it's reinforcing warming temperatures because our forests, i.e. the carbon sinks, are being destroyed by the mountain pine beetle. In the future, we need more science, more research to understand how specifically the mountain pine beetle outbreak is affecting climate modeling and to understand the future of climate science.